Hello everyone, so welcome back to our channel. Today we are going to discuss the independent topic of class 11, that is the basic of atomic models. Two models we are going to discuss here of Thomson atomic model and Rutherford atomic model. So as you know that Thomson atomic model have a great impact on our some basic concepts of chemistry. In later on topics you will find all these numericals based on Rutherford atomic models. So this one is a basic lecture which will provide to help in future videos. So here's about the first atomic model, that is Thomson's model. Thomson's model was discovered by J.J. Thomson in the year 1898. He was the first one to discover an atomic model, which is also known as plum pudding model and watermelon model too, due to its structure. Here you see the plum pudding model concept. What is there, why it is called the plum pudding concept, why this model is known as watermelon model, we will see here. Spherical neutrality. British physicist J.J. Thomson proposed that atoms are positively charged lumps of matter. So what J.J. Thomson proposed, that he said that atoms are positively charged lumps of matter. Lumps means like a circle or a part of matter which have only small ratios in it, with electrons embedded in them. Electrons are of negative charges and it is embedded in them, means it is like present inside. As if you have seen watermelon, how the seeds are present inside the watermelon red part, the seeds are here electron. You see, this one is the image of our Thomson atomic model. This is the structure of Thomson atomic model and why it is called the plum pudding model or a watermelon model. We will discuss over here. You see, the red color part of the sphere is of a positive charge, and the blue one, which is of negative, it is embedded negative charge, which is electrons. So this one is a red color part is a watermelon sweet part, and the negative, which are electrons that are considered as seeds in a watermelon. Okay. So ditto same to the theory of the watermelon is considered here in the Thomson atomic model. So it is known as plum pudding model. What? The red color part is our straight part of a watermelon, and the negative part, which is the electron, is the seeds of the watermelon, here considered as the electrons. So I hope you have got to know about the Thomson model of the atom. So the plum pudding model is also known as the Thomson model is also known as plum pudding model, which we have already studied. This one is also known as watermelon model, and it is also known as raisin fruit cake. Raisin fruit cake means it is a fruit. It is a cake which consists of fruits, different kinds of fruits, such as fruit cakes have a different quantity of fruit items like apple, etc. in fruits. So now, primary benefits. It successfully explained the overall electrical neutrality of an atom. What is the benefit that it this plum pudding model or the Thomson atomic model had successfully proven the electrical neutrality, that an atom has the atom is an electrically neutral. It has proved by the plum pudding model or Thomson atomic model has proved that the atom is electrically neutral. So if a question comes, who have proved that the atom is electrically neutral, you have to write the answer is J.J. Thomson. Thomson model of an atom, we have seen the purpose of this atomic model of J.J. Thomson, and now there are many limitation or drawbacks in the model of J.J. Thomson. What was that? The first one is mass disruption. Incorrectly assumed the mass was evenly spread across entire atom volume. So the volume of the atom was incorrectly assumed. It was not proper to that of an actual number, and the static electrons fail to deflect dynamic movement or arrangement of electrons. So while the electrons are moving here and there, so there are dynamic movements in the electrons, but the model only proposed the static electrons, which are steadily straight, doesn't move here and there, but fail to describe the dynamic movement of electrons. Structural stability couldn't explain the atom remains stable despite of electrostatic force. Scattering results. Contracted later experimental data to show contracted mass centers. It doesn't show the scatters of electrons in a different way. So these were the limitation of J.J. Thomson model. So here are the scale comparison between atom and nucleus, that radius of an atom divided by radius of a nucleus is 10 to the power 5, and volume of an atom divided by volume of a nucleus is 10 to the power 15. These are the two main theories of this atom versus nucleus. This is mainly an important one. Radius ratio of an atom, radius ratio is 10 to the power 5, volume ratio is 10 to the power 15. It is very much important for our basic theories. So this was our Rutherford, this is our Thomson model of an atom, which was discovered by J.J. Thomson in 1898, and there were many much speculation about this model. It is a popular atomic model too, as it describes the atom is an electrically neutral. It have many drawbacks, but forward the theories goes on and it is resolved by one another. Then further on, after Thomson, we will read the Rutherford model of an atom. So for this today it is this much, and hope you like this video. So keep practicing this all concepts. It will be helpful for our upcoming topics in the some basic concepts of chemistry. And remember, this is the independent topic of class 11th chemistry, which will be turning into a basic concepts of class 11th and class 12th. In physics also, class 12, there are atomic models chapter is there. Atoms and nuclei chapter will come. You will learn also study there too the atomic models of Rutherford, Thomson, and Bohr's atomic theory will be also been taught. So this is for today. Hope you like this video, and thank you for watching. Subscribe to our channel, and have a nice day. We will meet in next video. Till then, take care.